Hi everyone, hope you are doing well. Today we are going to talk about batteries and in particular this Bosch e-bike system Powertube 500. If you own an e-bike or plan to own one, then you might have realized by now that the most expensive parts of an e-bike are the motor and the battery. And the thing about the Bosch e-bike system is that it doesn't accept any other kind of battery except for a Bosch. So it's not just a matter of finding a compatible 36 volt battery, which is what this is. If you can see, there you go, 36 volts DC, 13.4 amp hours, which makes it 500 watt hours. So, as I was saying, it's not just a matter of finding a compatible 36 volt battery and connecting it in parallel with this one. No, they had to make it more complicated than that. So it's not just a matter of plugging in plus to plus and minus to minus. The Bosch BMS, the battery management system, actually communicates with the e-bike, or precisely communicates with the controller in the motor. So no Bosch BMS means no power, and I've actually tested it. And upon connecting the bike to basically plus to plus and minus to minus, the bike actually powers on, but you have no assistance whatsoever. So the motor does not come on at any point. It's just the display that comes on, and that's it. So if you like long rides or if you just don't like to have range anxiety, then the bottleneck in our system is the battery. And actually the biggest battery in my knowledge that Bosch has for their e-bike system is a 750 watt hour power tube, just like this, and a little bit taller. But the thing is, it's not just you can't just mix and match batteries. So it's it's basically manufactured. The bike is manufactured around the battery, and they're not cheap either. So basically, for what I found on the internet, each PowerTube 500 will set you back 500 to 650 euros at least, depending on where you buy it. So I asked on Reddit and on YouTube, and basically no one had a solution for this problem. I was told that Bosch has their system on lockdown for whatever reason, and I just couldn't accept that. And I mean, Bosch and no one else for that matter has a monopoly on electricity. So if you buy something, if you buy a car, for example, you can use whatever fuel you want on it. You can change the motor as you like. You can change the tires as you like. And apparently the same thing is not, or at least the companies that are the most, not most of them, but some of them are trying to kind of normalize this new way of doing things, which is kind of you buy something and it's not really yours to do whatever you like with, and you're always slave to the parent company. Just armed actually with all the knowledge that I've gathered over the years, and basically messing about with electronics and stuff, I knew of course that it's in principle it's possible, but I just had to test it, and here's how it goes. So suppose this is the Bosch battery in which we have our 10 cells. So it's a 10S, and the 10S just means that you have 10 cells. Basically each of these cells is composed of I think 3 to 4 cells, unit cells, and 10S, which means 10 cells in series, times 3.6 volts, which is the nominal voltage of the lithium ion Panasonic cells I think they use, and which gives you 36 volts nominal voltage. Okay, and let's say that this is the positive tap, negative tap, and then you have the BMS, which is basically just a circuit board which controls or which monitors, because you have these balancing wires, they are called, which come to all of the cells, basically just like this. And it's important to monitor the cells if they are basically in equilibrium, especially during charging, because the lithium ion cell voltage should always be between a max of 4.2 volts, and as they can go as low as 2.5 volts, but it is actually recommended to not take them below 3 volts, which is what I do. Okay, so then after the BMS you have your positive terminal, your negative terminal, and with the Bosch BMS and with the Bosch battery, and as well as some other manufacturers out there, they also have these three communication wires. So if you can see like this, so this is the negative, the positive, and then you have three extra wires, 1, 2 and 3, which are the communication wires. Okay, so let me just draw this again. So this is the Bosch, okay. So the principle of this is just to, if you have your second pack, which necessarily needs to be a 36 volt battery, a 36 volt battery nominal, which if you know your batteries, the voltage varies between, let's say, for what I like to set my BMS to, if I have a smart BMS, that is between 30 volts, which is 0%, and 42 volts, or what I like to do is 41.5 volts, which is 100%. Okay, all right, so you have your battery. Your battery of course has its own BMS. You charge it apart, of course. You have your positive and negative. That's all you need in a normal battery, and in principle you just connect them in parallel like this before the BMS. That is important, because what I did at first was, because I just didn't want to open the battery and not mess with it too much, because as I said, the batteries are very expensive if you have no battery, and precisely if you have no BMS, even if the battery is okay, you have no e-bike. Okay, so you have your 36 volts battery. What I did at first was I tapped into, so this is the connector on the battery, okay, and between the connector and let's say that this is the electronic speed controller, which goes to the motor and all the other electronics on the bike. Okay, what I did at first, so let's say that these are the COM wires, positive and negative, is I tapped into this place right here. So no, like this and like this actually worked, but sadly it kept throwing errors. Basically the most common one, which I did expect from the beginning before I even tested it, which is error 550. Basically it has something to do with the load not being consistent or something. And I did expect it because, like I said, the Bosch BMS actually counts the amount or calculates the amount of current going out of the battery, and the speed controller also calculates the amount that arrives at the battery. So connecting the battery outside of the system causes there to be a significant difference between what the BMS sees and what the electronic speed controller sees, because this BMS only sees the amount of current that's coming out of this. And when they meet, of course, here you have, let's call this big I, and let's call this I1 and I2. So I plus I2 equals I1. So basically this is the sum of this one and this one. And because there's a significant difference, it kept throwing errors basically every 10 to 15 minutes. Sometimes I could even be riding for about 30 minutes without an error, and but still it was inconvenient, to say the least. I was happy with it, but I thought I could do better. And to actually, like I said, let's forget about this for now. So what you need to do is connect it from here before the BMS, so to these points. Let's call these A and B, and in this way the current, so there's, let's call this I1, there's I2, and let's call this big I. So in this case I is equal to I1 plus I2, and in this way the intensity that the BMS sees is the same intensity that goes out, this one, which is I out from BMS. In that case, the motor does not see a difference, so no errors whatsoever. And the only thing that you need to make sure of before connecting the external battery to these points, to A and B, because you will actually need, this is where you need to tap into the battery like this, and you need these to come out of the battery. So if you can see, I have two sets of wires coming out of the battery. So this is where I connect my second battery. So if you were following me, this is positive, which is this one, so this is A, this is B, okay, this point and this point. What this one is, I will explain in a second. So as I was saying, one very important step that you need to make sure of is to monitor both voltages of the batteries before connecting them, because voltage, just like heat and pressure, it always goes from high potential to low potential. So if you connect the two batteries and suppose that this one is 40 volts at the moment and this one is discharged, let's say it's at 30 volts, that is a no-no. You should never do that, because there will be a rapid discharge of this battery into this battery until they reach equilibrium, basically. So that will be I don't know, tens of amps, if not hundreds of amps, depending on what the battery is capable of, and also the wires. So that is a huge fire hazard, and if you don't know what you are doing, you are better off taking your batteries to a professional. But if you know what you're doing and you like messing up with stuff, you at least need to do your research before trying stuff that you don't know. In any case, having made sure that the voltages are similar, so if they are 40 volts, the other one is 40 volts, there is no difference between the two, so in that case you are okay. What you normally should do is to make sure to charge the Bosch to 100%, to charge your battery to 100%. That brings both voltages as close to 42 volts as possible, and in that case, even if there is a minor equilibrium between the two, that means some current will go this way or this way, and sometimes it could even oscillate. It goes this way and until it reaches a certain voltage and it goes the other way. Once they are both charged, then you connect them. But there is a simple solution to all of this, which is what I'm going to discuss. And just to modify our diagram as it is right now, because you actually don't need to do much to it besides add one little component, which is a diode. Okay, so what a diode is basically it allows flow of electricity one way and not the other. Okay, so in this way, for example, if we only put one diode right here on the line that comes from the second battery, when the Bosch battery has higher voltage than the second one, there is no risk of back current rushing into our second battery. On the other hand, because we are only using one diode, if this battery is more charged than the Bosch, we do have the flow of current, because current will still flow like this into the Bosch until there is equilibrium. So to avoid this, you use the exact same trick, which is to put a second diode right here. And in this way, when this one is more charged than this one, the current can come here, but it can't go into the Bosch battery. The same with the Bosch. If it's more charged than this one, the current could come out. Of course, it always goes to the BMS, but it can't go back into the second battery. So basically 2 diodes, that's what you need. But there is even a better solution, which is a Schottky diode. So what a Schottky diode is basically, so I hope you can see, 2 diodes, okay, which one comes from this leg, one comes from the other leg, and the out is the leg from the middle. As you can see, that's one diode and the second, and the model number is the MBR200PT, which basically means it can run up to 60 amps continuous, I believe. And basically for my application, I think I use way below 20 amps. I don't know, at least below 30 amps, so that's, you have a lot of leeway that way. And it can stop a back current of up to 200 volts difference. So if you have, for example, one battery at 0 volts, the other at let's say 190 volts, there will be a very minimal back current flowing from the high voltage to the low voltage. I believe, if I will show you the data sheet, I believe it's something like 10 milliamperes or something like that, 50 milliamperes. I will show the data sheet on the screen. But in any case, this is the best diode to use in a power application like this. And just to show you, if you have a multimeter like this that has diode mode, you can measure the voltage drop between basically this point and this point, because as you are using a diode, this diode has some losses which manifest in a voltage drop usually, at least for the Schottky diode, as I will show you right away. And these I got after, which are basically the same, and they are actually the same family, the MBR 3060 PT, which just basically means up to 30 amps and 60 volts. They can stop a back current for voltages up to 60 volts difference. So I can use this, or I can use a higher rated one. This one will be fine. I just actually went with the other one because it was a little bit larger, and I thought, because I will be putting this component inside of the battery, that it being a little bit larger will kind of help with heat dissipation, because if you pay attention, this is usually screwed into a heat sink with a thermal pad or some thermal paste behind it. So as I was saying, voltage drop between these points. So this is the out, this is the in. So as you can see, with the positive from the out to the negative, there is no flow of electricity. Okay, when I inverse the leads, it will be the same, by the way, like this for the other part. Okay, when I inverse the leads, positive on the in and the negative on the out, as you see, 0.2 volts, so 200 millivolts, and it will be the same for the other one. There you go. So that's basically why I've chosen the Schottky diode for this role, because it has amongst all the diodes, I think there must be something better for for specific or certain industries, but for our application this is very good actually, because usually a diode can drop voltages up to 0.7 volts, or sometimes up to 1 volt, the normal diode. And as you saw, this one only drops 0.2 volts. Okay, so it actually depends on the amps. So as if you, let's say, so for example, for this diode, let's say at a certain point you are riding your bike and using both batteries, and you are running let's say just for the sake of ease of calculation, 10 amps on this diode, or on this leg of the Schottky diode, which means you will have times 0.2, you will have a drop of 5 watts. So this Schottky diode will basically waste 5 watts as heat. And the same will be true for the other leg. So in total you can waste up to 10 watts in heat that's running with 20 amps continuous. Of course you will never be running with 20 amps continuous unless you are going up a hill or something like that, or for some power application that's really demanding. And yeah, basically that's it. So let's modify our diagram again. So this is the symbol for the Schottky diode. Okay, and let's go actually to another page. So here we have our second battery, 26 volts. Here we have the Bosch. BMS. And the comms. Okay. So what you need to do, let's draw the Schottky diode right here, and I will draw it with 2 legs, 2 ins and 1 out. Okay, and basically this out will come right here. Okay, let's call this C, and let's call this D. And D is usually just because this is the positive negative, usually the positive line is run sometimes into the BMS, but it is still just, it comes in and it goes out right away. So between here and here there's no voltage difference. Okay, it's the same voltage here as it is here. Okay, next you have one connection from the Bosch battery itself, so that's like this. The second negative will come from your second battery. Okay, and this one will just come and connect anywhere to this point, D, or here or here. Okay, so that's basically the gist of it, which means that you will have current like this, current going like this, current going like this, and never the reverse in this direction or in this direction. So that's basically how we want to do it. Actually, because we call these, we called them A and B earlier, let's keep them like that. So this is A and B. For the knowledgeable amongst you, you will find that there is a slight there's a slight little problem with our system as it is right now. Okay, what is that? When you come and connect your charger, okay, so that means that the current is flowing the opposite way as from when you are using the battery, when you are discharging it. Okay, and remember what the Schottky diode does, or any diode for that matter. It prevents current from going this way or this way. We don't actually care about this one because this one we charge separately. But if you want to charge your Bosch battery, you cannot charge it like this because the diode will always be in the way of the current that is needed to flow in a certain direction to charge the battery. So then what you need is basically here where, if you remember, this is where we cut normally. This is the normal line that's going like this. Let's call this C and D. You need two wires. Let's run them like this. Okay, coming from the battery also, and that is actually what this second line is. This is basically a bypass, as you can see. Just momentarily I've just put a piece of wire, copper wire, inside of it to make the connection between this one and this one. So this is C, this is D, or vice versa. This is D and this is D, and this is C. Okay, and what this does when it's connected as it is right now, so like this, is that it allows you, it bypasses all the modifications that we've done earlier. Okay, so it does it just takes the Schottky diode out of the equation and it works as if we had done nothing to it. Okay, and actually this serves two purposes. When you are charging it, you absolutely need to put this in place, and also when you are using this battery alone, meaning if you are not using this one with it, because for small rides you can always just take the Bosch battery. It's lighter, it's it's much faster, and you can leave your second bike at home. So when we are using it alone, there is no, or just my opinion, of course you can use it without this connection right here, but when you put this line right here, the current comes like this and it comes out and it goes in, bypassing the whole Schottky diode, allowing us to have no losses because of the because of the diode. Okay, so that's that's an advantage. Of course, the losses are not much, just from let's say 1 watt to 10-15 watts at most, if that. And when you want to connect the second battery, and just to demonstrate, here I have a battery, and just to show you, which I have in this little flight case. So as you can see, it is almost fully charged. Okay, this is the XT60 connector that comes from this battery. And of course, once I have the Bosch battery installed, as you can see, it is fully charged at the moment. Okay, so once it's on the bike, once I install my second battery, which I could put on the rear rack, I prefer to put it on the top tube of the bike, which makes the weight of the bike, centralized. And you connect it. As you can see, no sparks, because usually when there's a rush of current one way or the other, you can hear a spark. And as you can see, the battery is still working. But in this configuration, like I have it right now, it is as if the battery is not connected, because if you remember, we have our bypass. Okay, once I take this out, then the Schottky diode will come into play. Okay, so when you are using the two batteries, you absolutely need to make sure to take the bypass thing out. Okay, I will actually, once I receive these connectors, I forgot what they are called, I will just have this. So this is the female, I will have the male connector and connected, bridged between the two terminals. That way, if it's on, that's bypassed. If it's off, it's not bypassed. So that's the gist of it. That's the principle of it. I hope that you understood everything. Of course, if you have any questions, you can always ask me in the comments. All that's left, I will just show you how I did the connections inside of the battery. One thing you also need to make sure of is this battery indicator button is actually just, if you can see, it comes from here and it's just glued to the case. So you absolutely need to make sure that you get under it with a knife or something sharp and peel it off. Like this. You can see it's just glued, and try to keep it off. And next, you will need some kind of mallet, but since I don't have one, I will just make use of this tissue along with this hammer and holding the battery upside down like this. Actually, I think we also need to take this front cover off. And this is actually the first time I'm getting into this battery since I made the modifications, and I was planning to do this just to to see how everything worked out, if there's no excessive heat problems from the Schottky diode, which we will see. Oh, actually I can just push. I will use this side of the hammer. It will kind of be a little difficult to get this back inside again, but this was necessary. So as you can see, I just made a hole I first used the soldering iron and took out one of these. This is a connection point. Took one of these out, drilled the hole and passed basically three wires through it. So that comes in from right here, and basically this is where the Schottky is. This is where I've put it inside. As you can see, I just had to this foam was kind of like this one in the beginning, just between the BMS and the top or the bottom side, and I just made a little cut through it to make a place for the Schottky diode. And as you can see, I don't see any signs of excessive heat nor anything, so normally everything is going just fine, as you can see even under it. Okay. Alright, so basically just after looking around and at the battery, and I realized that I made a little mistake, but it doesn't actually change a whole lot. As I was saying, normally most BMSs, they run the negative line through the BMS, okay? But in the case of the Bosch, it's actually the positive sign, the positive lead that is run through the BMS, and the common one between the two batteries when you connect them is actually the negative one. So basically you just inverse this. Wherever there is a plus, it's a minus, and basically that's this is the same diagram as in this. So this is the most negative terminal of the battery right here. This is the most positive terminal. That's a voltage of 39.3 volts, which makes it about 90 or 80% charged. Okay, so from the negative terminal we have these two wires, which are the same as negative, so it's this one. And if you put this into continuity, you can see that between this and here it is the same line. Okay, yeah, so this is the wire that goes into the BMS, the red wire. Okay, this one. So the most positive part of the battery is this. You solder a wire into it, into this tab. It comes and it goes to this leg. Okay, the second comes from the outside, as we said, from the blue wire, and here it comes, and it also goes to the second leg of the Schottky diode. Then the out of the Schottky diode comes and goes into this wire right here, which is the positive that goes into the BMS. And then after that, there's the the usual wires that come from the BMS, red and black, and the communication wires, as I said, which are right there, which then comes outside. Okay. And as for the bypass, it's basically between here, where the positive goes into the BMS, and right here, which is the most positive tab of the battery. So when you connect this to this, that's basically as if you had not modified your battery. So yeah, just to mention it, this red wire was actually connected here. Okay, there was no brown wire. The black wire actually it was here. It's the most negative from the battery, and what I did is add this most negative, which comes out. The second one is this one, which is the positive, which also comes out to the bypass. The third one, this one, which comes again to the bypass, and when you connect them, it's as if you put things the way they were. And lastly, so there's this positive part that goes into the Schottky. There's the other positive part that comes from the outside through the blue wire, which goes also into the Schottky. And lastly, the out from the Schottky diode comes into the voltage line that goes into the BMS. Okay, so basically you just need to follow the diagram, as I said, and as I said, for the Bosch battery system, it's actually the positive line that goes through the BMS. So as you can see from these diagrams, wherever you see a plus, it's a minus, and wherever there's a minus, it's a plus. Okay, so time to put the battery back together. Alright, so one last thing I forgot to mention was concerning the charging of the Bosch battery after the modifications. So if you can I've plugged in the Bosch charger, and as you can see, you plug it in like this. And for those who have a Bosch battery amongst you, you know that this light comes on, and after 2 to 3 seconds it starts flashing the remaining charging blocks, if you will, or the remaining charging level. So if it's 4 bars full, almost full, there's gonna be only the fifth one that's gonna be blinking, like it should do right now. But like I said, without a bypass, here we go. So it does detect the charger, but it does nothing. Then it just turns off, because without the current being able to flow, reverse current basically through the diode, there is no charging. But check this out. Let's just leave it like that. As soon as I take, so as you can see, it tried to charge again, but the light just stays on. And as soon as I take this, or preferably I will disconnect the charger, put this bypass in place, and it shouldn't spark or anything. It just links two sides of the it just basically returns the battery the way it was before any kind of modification, except it's on the outside. And plug in the charger right now, solid light, then it's gonna start blinking. So it's this way. So as you can see, there you go. And for example, if I take this out, the charging stops. Okay, so that's as far as the charging is concerned. The one last thing that I forgot to mention is that you can do basically the same thing to as many batteries as you want. So for example, I just demonstrated how to connect the second battery, and if I ever want to put a third battery on my e-bike, it's the same principle. And just to show you, so the second battery, the Bosch battery, second, let's call this one the third battery. Positive, negative, positive, negative. So like I said, for the Bosch system, it's the positive lead that goes through the BMS. So here is basically BMS. Here we have I'm just drawing it as I drew it before, but you understand what I mean. The Schottky diode, and basically to connect the third battery you need to do the same manipulation we did right here. So another Schottky, this one will come to the second battery this time. Yeah, sorry. This one will come, this one will be the output this time. So in this case it will be, so this is the second, third, and in this case it will be like this. And then we reach the Bosch. Then we have the second Schottky. And these are basically all connected together between them. And in this case, one of the inputs into the second or this is actually the first Schottky, is the output of the two batteries combined in parallel. Okay, so basically you can do this as as many times as you want, and each time you add a battery you add a Schottky diode, and of course each time you add a Schottky diode there's small losses. But what you need to know is that actually when you have I1, I2, I3, I4, and finally I5. So when you have connected these two batteries together, the current that's coming from them is actually divided between the two depending on the capacity, but assuming that the capacities are similar. So if this battery is the same in the exact capacity, voltage is a given. Okay, I will not discuss voltage anymore, but given the capacity, you will have the I1 equals I2, and I1 plus I2 equals I3. This is true no matter what. Then because you have I3, if you had only this first battery, this I3 would have come all from the second battery, but because we added the third, this I3 has been divided by 2, basically by half. Okay, so that actually reduces the load, making the doing things this way actually reduces the load for the first battery and the second battery. And of course these two combined together, which have this current coming from them, means that, of course, depending again on the capacity, so this one we have 13.4 amp hours, and let's say that these are 15 each, that makes them 30 amp hours. So it's basically almost half. And what will happen in this case, the same thing that happened in this case. So I4 no, it's I3 will equal 2 times I4, because this one will give twice the current as the Bosch will. And what actually controls this current, this flow of currents and everything, it's just potentials, voltages. Because when you have these two batteries connected in parallel, the current that will flow from I1 will equal the current that will flow from I2 as long as the voltages are similar. Okay, if this one, for example, dips a little bit below, the current I2 will stop completely, and it will be the second battery that will give all the current until the voltage equalizes again. Then they will give both half and half to make I3. So I hope that was a comprehensive explanation, and that's it. And basically that's it. If you have any questions, you can ask me about them in the comment section. I forgot to mention these Schottky diodes you can find, I believe, anywhere. I bought them on AliExpress and they were very cheap for what they are. I believe $4 or $5 for the set of 5 of these, which are the 3060. And I believe for this one I paid something like €7 for a pack of 3. So quite the useful electronic device, electronic component. I'm very happy with my system right now, and like I said, no one has a monopoly or should have a monopoly on electricity, because a battery is a battery. Of course, there's a lot of things to know to do your stuff yourself safely, but knowing what you're doing, you can basically you should be able to run your bike on any battery as long as it's a compatible voltage battery. I hope that was a good explanation, even though if it was a little bit too long. I wanted to do a comprehensive explanation, and of course for the knowledgeable among you, you will directly just seeing the diagram, you will know what I'm doing, and for everyone else, you can follow this step by step. You still need, and I do need to say this again, you still need to know what you're doing, because messing with batteries can be a bit dangerous. And if you short circuit something, if you are careless using middle tools and stuff, you can easily at least scare yourself or piss your pants, if you will. In any case, I hope that was helpful. If it was, please leave a like. Otherwise, you can subscribe. And yeah, until next time, this was the Electron Age. Bye.